Guys, today we're going to continue talking about two-step equations, and we're going to look at some equations that maybe don't look like two-step equations, but they actually are. So the I can statement we're working on is I can solve two-step equations fluently, and I can identify the sequence of the operations used in each approach. And when I'm solving equations, I like to think that I'm a detective, right? So detectives start at the scene of the crime and work it backwards to see who the criminal is. And that's very much how we solve equations. We work the order of operations backwards. So first we're going to undo the addition and subtraction, then we're going to undo the multiplication and division, and next week we'll start to see when we undo exponents or parentheses. So let's look at this equation. 3j plus 8 plus 2j equals 78. Now it doesn't look like a two-step equation because there's three terms there, but it really is. Do you remember in our last unit on algebraic expressions where we had to simplify the expression? Well, that's what we're going to do with the left side of this equation. We're going to simplify this expression by circling the like terms. So 3j plus 2j is 5j, and 8 doesn't have anyone to combine with, so we're just going to put plus 8, and that's going to equal 78. Now I have what looks like a two-step equation. So what operations do I have in this equation? Well, 5 times j, I have multiplication, and plus 8, I have addition. So what am I going to need to do? I'm going to need to divide and subtract. And because we're working the order of operations backwards, I'm going to subtract 8 from both sides first. These 8's cancel out. I'm left with 5j equals 78 minus 8 is 70. Now I'm going to undo my multiplication with division. So I'm going to divide by 5. Fix that. And I will get j equals 14. Now, I believe that's correct, but I still need to check it. I'm going to go back to my original equation and substitute 14 everywhere I see a j. So here we go. 8 times 14 is 42, plus 8, plus 2 times 14 is 28, and that should equal 78. So 42 plus 8 is 50, plus 28 is 78, and 50 plus 28, oops, sorry about that again. 50 plus 28 is 78. Does that equal 78? It does. So j equals 14 is a good solution. Here we go. Here's another equation that doesn't look like a two-step equation, but it actually is. I'm going to have to simplify the left side first. And in this case, I'm going to have to simplify by distributing that 4 to every term inside the parentheses. So 4 times t, sorry about that, 4 times t is 4t, minus 4 times 2 is 8, and that's going to equal 12. So now I have what looks like a two-step equation. What operations do I have? Well, I've got multiplication and subtraction. How do I undo multiplication? With division. And how do I undo subtraction? With addition. So, because I'm working the order of operations backwards, I'm going to add 8 to both sides. 12 plus 8 is 20. These 8's cancel out. I'm left with 4t over here. Now I'm going to divide both sides by 4 because I want to get t alone, and t equals 5. I believe that's my solution. But before I go ahead and say I'm done, I'm going to check it by substituting 5 in for t. So 5 minus 2 is 3. 4 times 3, does it equal 12? It sure does. So I know t equals 5 is a good solution. All right, we're done with this video. There is no summary There is no work. I just wanted you to watch it so you can go ahead and do the practice. Have a good day.